Yesterday we were anyone of we are going to
Ma'am, your voice is breaking.
that might be because okay. I'm continuing the lecture. If my voice continues to be breaking, please inform.
Ma'am, your voice is too small.
It's too low and too cracking.
Okay, now my voice is clear. Now my voice is clear.
No,
Okay. Now my voice is clear. Hello. Am I audible?
so much of disturbance, ma'am.
Uh, Now is it clear? Am I audible? Okay. So yesterday we discussed about okay. So I think yesterday's table, this table is quite unclear. So I will be creating a new table so that it would be clear to understand. So yesterday we followed strategies used by sending host. My screen is visible, right?
Yes.
Okay. See, all of you, please pay attention to this lecture because this will make a confusion whenever you are going to read it from the book, right? So please make attention, and this topic is really important. It may be asked anywhere, right? Because many of the questions can be asked from these topics, right? So uh, we followed 4 strategies. First one was always retransmit, right? Second one is never retransmit, right? This two we have completed. And today we are going to discuss about retransmit in S0 and retransmit in S1, right? So previously we have discussed that client can be in one of two positions. Either it would be in S1 position or it would be in S0 state. You can say state or position. Right? So if a client is in S1 state, that means one TPDU is outstanding, right? And if a client is in S0 state, that means no TPDU is outstanding, right? So this is the position of client, right? And sending host will be monitoring. हाँ okay. Okay, so this is the sending host. Right, so a sending host, what a sending host will do, sending host will check whether the particular client is in state S0 or is it in state S1, right? So there can be six conditions that can be strategy of a client, right? So yesterday we have discussed about all these six positions. So I'm writing it down and we will be discussing it with regarding retransmit in state 0 and retransmit in state 1, right? So these all are six strategies that a sending host will follow, right? So do not get confused about the client and the server, right? Because here we will be referring the server as a sending host, or you can also refer client as a sending host, because client may be requesting for some content to the server, right? So at that time the client may be a sending host, or a sender may be providing some content to the clients, right? So at that time the server will be a sending host. So with the names client and server, do not get confused, just you refer sending host or the receiving host, right? So there will be four strategies that can be followed by the sending host, and there will be six strategies that can be followed by the receiving host. Receiving host, right? Right. So these two things, I think these are clear because we have discussed it very well in the yesterday's lecture. So here, in case of retransmit in state 0, right? So check in this condition. First, the receiving host sends an acknowledgement. Because receiving host has already sent the acknowledgement, which state it will be following, S1 or S0? The receiving host will be in which state? I want answer from you. Yes, anyone? in first case, the receiving host is first sending the acknowledgement. So whenever a receiving host is sending the acknowledgement, state of that host will be what? S0 or S1? I'm audible, right? Okay, so I think you don't know which state will be there, right? So whenever, suppose I am a client and I am sending an acknowledgement, that means I have received all the TPDUs, right? So because I have received all the TPDU, that means no TPDUs are outstanding, right? So I will be in the state 0. Right, so I have sent the acknowledgement, but I have not done the right procedure because I have not written the content into my memory or the output stream. Before writing the content into the memory, I am crashing down, right? So receiving host is crashed. So because receiving host is crashed, the acknowledgement is a fake acknowledgement because you have not written the content to the output stream, right? So in this case, if a sending host is retransmitting in the state S0, so my receiving host will be in the state S0, and because the sending host is following the strategy retransmit in S0, it will retransmit the TPDUs, right? So TPDUs are retransmitted in this case. So it will be okay because the previous TPDU that I have received, I am the receiving host. The previous TPDUs that I have received, I have not written it down into my memory or my output stream, right? So I don't have the previously received TPDUs, right? So retransmission will work fine because I want it again, right? Let us see the second case. Right? So here the receiving host is sending acknowledgement, and the receiving host have returned the received TPDUs into the output stream, and then the receiving host crashes, right? So task is done, right? So because receiving host has sent the acknowledgement, the receiving host will be in the state S0, right? And the sending host, following the strategy, if the receiving host is in the state S0, please retransmit, right? So because the receiving host is in the state S0, the sending host will be retransmitting the TPDUs, right? But in this case, the previously received TPDUs are already written into the memory, right? So because it is already written, if retransmission occurs, it will create a duplication, right? So if I am the receiving host, I will receive duplicate TPDUs, right? I will receive duplicate packets. And in the third case, first the crash occurs and no acknowledgement or no right procedure has happened, right? So because no acknowledgement is sent, the receiving host will be in the state S1 because the state S1 means one TPDU outstanding. That means some TPDU, the latest, one means the latest. The latest TPDU is not received by the receiving host, right? So because the receiving host is in the state S1 and the sending host is following the strategy retransmit only if the receiving host in the state S0. Because the receiving host is not in the state S0, the sending host will not repeat the retransmission. Right? Content is not received at the receiving host. Before the read and write procedure, right? So because before the write and acknowledgement procedure. So because the write and acknowledgement procedure is not done and crash is happened, your receiving host will be in the state S1 and your and this will be the same case as the previous case, so your packet will be lost, right? Now coming to the fifth strategy, here first of all the receiving host writes the received packet into the output stream, and then it sends the acknowledgement, and then the crash occurs, right? So because I have already completed my task, I have returned the received packet into output stream, right? And I have sent the acknowledgement. Because I have sent the acknowledgement, I will be in the state as 0. And yes, my sending host is following the strategy retransmit in the state as 0, right? So it will retransmit. Because of retransmission, it will create a duplicate packet. Coming to the last strategy, first it follows the write operation, and then it crashes and acknowledgement is not sent, right? Because acknowledgement is not sent, it will be in the S1 state, right? It will be in the S1, yes, it will be in the S1 state, but it is not the actual state, right? Because we have already returned the received TPDUs, right? So we don't want the retransmission. So because the client, or you can say the receiving host, is in the S1 state, and and sending host is following the strategy that retransmit in the state as 0, that means it will not be retransmitting, and this strategy will be okay because it is already written, and my main task is to write the received TPDU into my memory. Right. Is it clear? Is it clear in the case of retransmit in S0? Yeah. So if this is clear, you can simply follow this retransmit in S1, right? So in this case, the state of the receiving host will be same. It will be the state S0, and because it has not returned and it is retransmitting in the state S1 only, right? So in this case, in the first case, it will not be retransmitting. Because it is not retransmitting, your TPDU will be lost, right? Because you have acknowledged it, you have not written into the output stream. Coming to the second case, my receiving host is in the state as 0, right? And my sending host is retransmitting in state S1. So here it will not be retransmitting, but I have already acknowledged the TPDU. I have already returned the TPDU into my output stream, but the crash occurs after my task is done. Because my task is done, this strategy will work fine. So it will be okay. Right. And here in the third one, the receiving host is in the state S1. Yes, I am following the strategy retransmit in S1. So here it will be retransmitted, and here crash have been occurred before the write and acknowledge procedure, right? Because the crash have been occurred and I have not written, or I have not done my task, this will be okay if I retransmit here, right? So here in the case, crash has been occurred, so it will be the same position as before. My receiving host is in the state S1, and my sending host is following the strategy retransmit in the state S1, and yes, it will be retransmitting, and crash has been occurred before my task is done, so this strategy is again okay, right? Coming here, my receiving host is in the state S0, and my sending host is following the strategy retransmit in S1. But because I am in S0, it will not be retransmitting. Here, let us see what happens. I have already written my TPDU. I have already acknowledged, so it will this okay. Right? And in the last case, I have already written it, and crash occurs, and acknowledgement is not sent, and you can see that my receiving host will be in the state S1. So because it is in the state S1, retransmission will occur. And because my task is done, right? My main task is to write the return TPDU into the output stream. So because I have already written it to the output stream and retransmission is again happening, it will create a duplicate TPDU. So as we have seen two strategies today, and as we have seen two other strategies yesterday, we can see that in any of the strategy you can find drawbacks, right? Either your packets are lost, either your packets are duplicated, and somewhere it is fine, right? So there is no way to escape from this condition, right? So it can be asked in MCQs that the sending host in the retransmit in S0, and one of this strategies of the receiving host will be given to you, and I can ask you that retransmission will happen, and what thing will be there? Is it will it be following the duplication, will it be following the lost packets, will it be following the submission okay, right? So MCQ can be asked from this topic. Right? So this is all about the crash recovery. So is there any question? Is there any question in this topic? I think there is no more questions, so I'm going forward to the next topic, which is user datagram protocol, UDP. So if you are facing any problems in understanding this table later on, you can ask anytime, right? Because it may take time, because if you have not paid enough attention into this lecture, might not understand this. Right. Our next topic is Internet Transport Protocols. So we have generally two Internet Transport Protocols, TCP and UDP. UDP and TCP. Does anyone can tell me the TCP and UDP? What is UDP?
Transmission control protocol, user datagram protocol.
Yes. Please be interactive in the lecture, otherwise you will get bored and you will not find a way to memorize these things while you are preparing for the exams, right? Yesterday I have explained the way what is a connectionless protocol. What is a connectionless protocol? What is a connectionless protocol? These are the basic questions, right? Even after you complete your BE, you will be encountering this type of questions in your interviews, right? What is a connectionless? What is a connection oriented? What is UDP? What is TCP? Everything is very important. Whenever the connection between the two entity is established before the sending the packets, that is called connection oriented protocol. And whenever the connection between the two entities is not established before sending the messages, that means that particular protocol is connectionless protocol. So internet has two main protocols in the transport layer: connectionless protocol and the connection oriented protocol, right? So we will be studying both of this protocol. Your connectionless protocol is the UDP protocol, and your connection oriented so because UDP is basically just internet protocol with a short header added, we will start with the UDP, and we will also look at two applications of the UDP. Right, so today I think we might be covering the introduction to UDP. So your internet protocol suite supports the connectionless protocol UDP, right? That is user datagram protocol. Right, so UDP provides a way for application to send encapsulated IP datagrams and send them without having to establish a connection. Right? So it will be transmitting segments consisting of 8 bytes of header followed by the payload. Right, so it will be transmitting the packets. There will be UDP length will be 8 bytes of header plus what is a payload? What is payload? See, because I have not taken the whole subject, I might pronounce some words that are not clear to you people, because I think this payload word might be explained before in the previous lecture, right? But you don't know. So if you don't know the particular words, you can ask that what is this? Right? Because I'm taking this subject from the middle of your semester, right? So payload is the data, or you can say a message. Yes, so UDP will be transmitting 8 bytes header. This will be header. So you can divide the UDP packet or UDP. Yes, and rest one will be message. So whenever a UDP packet arrives at a destination machine, its payload is handed to the process attached to the destination port, right? So this attachment will be occur with the bind primitive or something similar to the bind primitive, right? So whenever you want to attach the payload to the destination port, the bind primitive will be used. So the source port is primarily needed when a reply must be sent to the source. By copying the source port field from the incoming segment into the destination port field of the outgoing segment, the process sending the reply can specify which process on the sending machine is to get it. So your UDP length field will be including 8 bytes of header and data, or you can say the payload. And there will be a UDP checksum which is optional. So the UDP checksum is optional. So this checksum part will be set to 0 if it is not computed, right? So I think you are aware of the word checksum, and if you are not aware, we will be covering it in the upcoming lectures. So it will be checking the integrity of the message, right? So if a checksum is not set, it will be set to 0, right? And you will be setting it to 0 only if the quality of the data doesn't matter, right? So it is probably worth mentioning explicitly some of the things that UDP does not do, right? So what things UDP does not do? UDP does not do the flow control. It doesn't do the error control because the connection is connectionless. It is not following the flow control. It is not following the error control, and it is not doing the retransmission. So all of this is up to user process. So UDP will not be doing the flow control, it will not be doing the error control, it will not be doing the retransmission. Same these things will be followed in the TCP. TCP will be doing all these things, but UDP does not do all these things, right? So what it does do is to provide an interface to the IP protocol with added feature of demultiplexing multiple processes using the ports, right? That is all it does. So the application that needs to have precise control over the packet flow, error control or timing, UDP provides just what the particular application needs. Right? It does not provide the more functionalities like flow control, error control, and retransmission. So where this UDP is especially useful. So the area where the UDP is especially useful is the client server situations, right? So often client sends a short request to the server and expects a short reply back. So in this case, UDP will be useful, right? So it will be sending a short request and it will be receiving the short reply. So where we need a short request reply functionality in the DNS server, right? So the domain name system, right? So basically in the DNS server, or you can say DNS system, the domain name system, this protocol UDP is used, right? And there are some real-time applications. So in the real-time protocol, the UDP protocol is used, right? So these two applications we will be discussing about this real-time uh, transport protocol and the remote procedural call in the next lecture. Right, so I would recommend you people that just read the concept of crash recovery and the user datagram protocol from the book. I think you are having the book. I'm following the book Computer Networks by Andrew S. Tannenbaum. Right, I'm writing the book name. If you want to take a screenshot, you can take it. Is Computer Networks and author is Andrew S. Tannenbaum. This book I'm following. There are other textbooks also available in your syllabus. You can follow any of the book, and if you are facing any difficulty, you can contact me. So I think this is it for today's lecture. If there is any more questions, you can ask. And just wait a minute, I will be taking your attendance. I'm audible, right?
Yes.
Just a minute, I'm taking the. Okay, thank you everyone. You can leave.